We're continuing topic 5.2 with example 3. So we need to find the critical numbers. It was very explicit. For f of x equals x squared plus 5x plus 6 over x plus 2. We know to find critical numbers we must take a derivative, and it looks like we have a good old quotient rule, which we haven't done that in a while. So we've got the red, we've got the green. So we're going to take our derivative, f prime of x equals the derivative of the red on top. So the derivative of x squared is 2x. Derivative of 5x is 5. And then derivative of 6 is 0. Put some parentheses around that. Keep the green the way it is. So x plus 2. We know our operation in between is a minus. And then we're going to keep the red the way it is. So x squared plus 5x plus 6. And then we're going to take the derivative of the green. The derivative of x plus 2 is just 1. And then remember, we're all over the green squared. All right, to find critical numbers, we know we need to set this equal to 0. So I'm going to do a couple of things at one time. Okay. I'm setting that equal to 0 because I ultimately know that in order to solve this, I need to get this guy to the other side. To get him to the other side, I would just multiply. So 0 times x plus 2 squared is just 0. So I know that that's 0. At the same time I'm doing that, I'm going to do some FOIL here, and we're going to distribute this in. Okay, so we're going to simplify this left side at the same time. So 2x times x would be 2x squared. 2x times 2 would be 4x. 5 times x would be 5x. 5 times 2 is 10. Then we know when we have a negative in front of parentheses, we have to distribute. So I'm going to change all my signs. So it's going to become negative x squared minus 5x minus 6. All right. Then we are going to go ahead and combine our like terms. I'm putting like terms together. So I see 2x squared and negative x squared is just going to be x squared. Then we've got 4x plus 5x is, oh, look at this. This is even better. Look at that. 5x and negative 5x, those cancel. Woohoo. So we just get 4x. And then finally, find something I haven't used. We've got 10 and negative 6 would be positive 4. We're still equal to 0. All right, we've got a quadratic. It's equal to 0. It's a trinomial. I know I'm going to have to use the magic x, so I need two numbers that multiply to 4 and add to 4. We know that that is 2 and 2. So I get x plus 2 times x plus 2 equals 0. Or if I really wanted to, I could write it as x plus 2 quantity squared. So we've got x plus 2 equal to 0 by 0 product property, and x plus 2 equal to 0 by 0 product property. So I'm going to subtract the 2. Technically, it's just a double root. Usually what's going on with that is it's bouncing off the x-axis. So I know that one of my critical numbers is at x equals negative 2. Now, there was another part of that critical numbers definition. It was that if it is equal to 0 or where it is not differentiable. So that means that if there's a denominator, the one number or denominator is not allowed to equal is 0. So I would set my denominator equal to 0 because that's where it's undefined. So let's write that part down. So it's undefined when the implies that the denominator is equal to 0. So I'm going to take that denominator that we had. I'm going to set it equal to 0. So x plus 2 squared equals 0. I'm going to undo the square. So I'm taking the square root of both sides. So you get x plus 2 equals 0. And then I'm going to subtract the 2 to the other side. In this case, it happened to all be the same critical number. But it's possible that that isn't the case. So we know that our critical number is x equals negative 2.